This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today's topic is the non-homogeneous terms of the type, that is f of x is the function which is involving in terms of sin x or cos x. We discussed previously the non-homogeneous linear differential equation that f of x is a function whenever the function is involving e power ax is a function. Then how to find the solution we previously discussed. Today, in price of the e power ax, the function is which is involving in terms of sin x or cos x. First of all, we are going to discuss that what is a higher order linear differential equations with constant coefficients. Definition: an equation of the form that is a d power ny by dx power n plus p1 into d power ny by dx power n minus 1 plus p2 into d power of n minus 2 into y by dx power of n minus 2 plus up to so on, that is a pn into y is equal to q of x. Where here the values are, that is a p1 comma p2 comma up to so on pn are the real constants and q of x is a continuous function of x and is called the linear differential equations of order n with constant coefficients. Here we are going to discuss that particular integration. The particular integration is nothing but whenever the given equation q of x is a function which is involving any functions, then how to find the solution. That is, we need to assume that is a yp, that is a y particular integration is equal to 1 by f of d into q of x is a value. Whenever we are going to observing that q of x, these are the four cases available. One is a q of x is equal to e power x. Second case is a e power x is equal to like sin x or cos x. Third case, that q of x is equal to x power m. The fourth case, that q of x is equal to e power of ax into v is a value. That means here v is nothing but once again the fourth case, there is a sign combination or cos combination or x power n is a combination. In previously, the case 1 is discussed clearly. Now we'll go to discuss the case 2, that is a q of x is equal to, that is sin of ax plus b or cos of ax plus b is a value. According to the working rule, that is a y particular integration is equal to that 1 by f of d into, that is a q is a value. Therefore, that is 1 by f of d into, that is a 1 by f of d square into sin of ax plus r minus b is equal to sin of ax plus r by b by, you need to replace the d square is equal to minus a square is a value. That means, whenever the given function q of x is equal to sin of ax plus b or cos of ax plus b, we need to replace that directly, d square is equal to minus a square is a value. In case 1, previously we discussed in terms of e power ax is the given function in q of x is equal to, we need to replace that d is equal to a is a value. But whereas here, the given function is involving in terms of sin of ax plus r minus b or cos of ax plus r minus b, we need to replace the d square is equal to the simply minus a square is a value. Whenever the denominator which is not equal to 0, that is a final solution. Sometimes when you are going to replace the d square is equal to minus a square, the denominator which is vanishes, that is equal to 0. Hence, that according to the working rule, you need to multiplying with x into the denominator derivative. Again, you need to replace the d square is equal to minus a square. That is nothing but x into, that is sin of ax plus or minus b by f dash of minus a square, provided here also f of minus a square, f dash of minus a square is not equal to 0. And similarly, the given function is a, like cos is also like that, same we need to apply, that is x into, that is a cos of ax plus or minus b by f dash of minus a square, provided f dash of minus a square is not equal to 0. If it is a f dash of minus a square is also 0, then we need to multiply 1 more x and again that 1 more derivative the denominator. Again you replace the d square is equal to minus a square. That means the reduce it to second time, that is x square into, that is a sin of ax plus or minus b by denominator f double dash of, that is a minus a square, provided f double dash of minus a square is not equal to 0 and until the denominator which is not equal to 0. Now we'll go to discuss according to that alternate method. It is also same, that d square is equal to minus a square. We need to replace that f of minus a square is not equal to 0. The particular integration sin of ax by f of a minus a square. And similarly f of minus a square is equal to 0. Then you need to replace that according to that once again that multiplication with x. Like further proceeding the denominator which is not equal to 0. Now we'll go to discuss that solve the d square minus 4 into y is equal to, that is a 2 into cos square x is a value. When we are going to observing here, that is a given equation is d square minus 4 into y is equal to 2 into cos square x. Here already given the function is a operator form. Therefore, we need to write LHS side, that is a complementary function with the help of that is auxiliary equation. That is f of m is equal to 0. Therefore, m square minus 4 is equal to 0. By solving here, that is m is equal to, you obtain that two roots. One of the root is 2 comma minus 2 is a value. With the help of that, this is a case, it is a case 1 applicable. The roots are the different roots. Therefore, the complementary function is equal to, that is c1 into e power of 2x plus c2 into e power of minus 2x is a value. Now we'll go to discuss that is a particular integration. When we are observing here in this particular integration, the right side is a q of x equal, that is a 2 into cos square x. But it is not in the standard form of sin ax or cos ax. We need to reduce it to in the standard form. Therefore, by using that cos square, we need to converting into 1 plus cos 2x by 2. That is nothing but, that is a 2 into, that is a 1 plus, that is a cos, that is a 2x by 2 is a value. Therefore, here the denominator, the numerator 2 is cancelled. The numerator is changed to like 1 plus cos 2x. The denominator, the d square minus 4 is a value. Therefore, we need to divide the two parts. One is a 1 by d square minus 4 plus cos 2x by, that is a d square minus 4 is a value. Here, when we are going to observing the first part, it is treated as pi1, that is a particular integration 1, and pa2 is the second part, that is a particular integration 2 part. First, we need to find out what is a particular integration 1. Therefore, ypa is equal to, that is 1 by d square minus 4 into 1. That 1 is nothing but, you assume that e power of 0x, because of e power 0x is 1 value. Therefore, e power of 0x by d square minus 4. According to here, it is the e power ax is the case is a 1. That is, you need to replace the d is equal to a is a procedure, like following with the help of the previous class, that is the first case, the type 1. Therefore, according to here, when you are going to replace the d is equal to, that is a 0, the denominator is clearly minus 4 is a value. Therefore, the particular integration 1, that is ypa is equal to minus 1 by 4 is a value. Now we will go to discuss, that is a yp2, that is a particular integration second type. There is 1 by d square minus 4 into cos 2x, and it is clearly according to the type 2, that is nothing but case 2. While we are going to following with the help of the case 2, it is a d square is equal to minus a square. And here, that a is nothing but it is a 2 only. Therefore, since according to, that is a cos ax is nothing but it is a replacement of that cos 2x, therefore a is equal to 2. Therefore, minus d square is equal to, that is minus a square is equal to minus 2 square is a value. Therefore, the d square is equal to minus a square is nothing but minus 4 you need to replace wherever the d square. Therefore, the solution is, it is clearly the denominator, that is a minus 4 is nothing but totally together minus 8. Therefore, that y particular integration part 2 is a cos 2x by, that is a minus 8 is a value. Now, according to the general solution of this given differential equation is a complementary function plus particular integration. By using here complementary function and particular integration part 1 and part 2, therefore, it is clearly the solution is a c1 into e power 2x plus c2 into e power minus 2x minus 1 by 4 minus cos 2x by 8 is a final, the general solution. Now, we will discuss, that is a solve d square plus d plus 1 into y is equal to, that is a sin 2x. And here also, we need to find out what is a complementary function as well as the particular integration. While we are going to solving that complementary function, it is a d square plus d plus 1 into y is equal to 0. Now we need to find out what is auxiliary equation. The auxiliary equation is nothing but you need to replace the d is equal to, that is a m value. By using the equation, the auxiliary equation, that is m square plus m plus 1 is equal to 0. Now here, the order of the auxiliary equation is a second. Therefore, while we are going to solving that auxiliary equation, we obtain that two roots of the given differential equation. Therefore, by using the synthetic division or something factorization method, the solutions are here clearly you obtain there is a minus 1 plus or minus I into root 3 by 2 is the solution. Therefore, here it is according to that complementary function, the solutions are according to the roots are the complex. That is by using the third case according to in the form of alpha plus or minus I beta is a value. Therefore, here the complex roots are minus 1 by 2 plus I into that is root 3 by 2 is a value. Now, we need to write according to with the help of the real part is a minus 1 by 2 that is e power of alpha x is a e power minus x by 2. With the help of the imaginary part that is root 3 by 2, then you need to write that is a c1 into cos root 3 by 2 into x plus c2 into that is a sin root 3 by 2 x is a value. Therefore, next we need to find out what is a particular integration. According to the particular integration is a ypa is equal to 1 by f of d into that is a q. Therefore, 1 by f of d is nothing but that is a d square plus d plus 1 into q is equal to that is a sin 2x is a value. Here, it is clearly in the form of that sin 2x is a value clearly that is sin of x plus or minus b. And here a is equal to that is a 2. Now we need to follow with the help of that procedure. Wherever the d square in the denominator, you need to replace that is a minus a square. Therefore, here you replace the d square is equal to that is a minus a square. Therefore, the d square is equal to minus a square is nothing but you need to replace the d square is equal to minus a square is equal to minus 2 square is a value. Since that a is equal to that is a value is a 2 is a value. Therefore, by using this condition here, that is a 1 by minus 4 plus d plus 1 into that is a sin 2x. After that simplification, the denominator which is a 1 by d minus 3 into sin 2x is a value. Here, it is not possible to directly simplification because of here the denominator which is involving in terms of d once again. But we need to require the denominator d square because of that q of x is required the sin of ax plus or minus b or cos of ax plus or minus b. Here, for the purpose of the case 2, the denominator it is required the d square is clearly. Therefore, now you need to do that by using the rationalize. The denominator it is already d minus 3. Now you need to multiply with d plus 3 by d plus 3. Therefore, the denominator it is clearly the d minus 3 into that is a d plus 3 is nothing but after that multiplication the denominator d square minus 3 square is equal to that is a d square minus 9 is a value. Therefore, it is clearly the numerator is a d plus 3 by denominator d square minus 9 into sin 2x is a value. Therefore, you need to once again the denominator according to the case 2 d square is equal to minus a square that is a minus 2 square. Therefore, it is a minus 4 minus 9 the denominator is totally that is a minus 13. The numerator is a d plus 3 into sin 2x is a value. Now, we need to once again that multiply with the numerator with sin 2x. Therefore, the first part is a d of sin 2x is nothing but the derivative of sin 2x. Therefore, the derivative of sin 2x is nothing but that is a 2 into that is a cos 2x. Therefore, remaining part is a 3 into sin 2x. But the denominator already it is a negative value is occur. Therefore, with the help of the negative value, that is a minus 2 into cos 2x by 13 minus 3 into sin 2x by that is a 13. Together, we need to write the general solution of the given differential equation is a y is equal to the complementary function as well as the particular integration. Therefore, here total solution the general is a y is equal to e power of minus x by 2 into c1 cos root 3 by 2x plus c2 sin root 3 by 2x minus 2 into cos 2x by 13 minus 3 into sin 2x by that is a 13 is a final the general solution of the given differential equation. Now, we need to discuss the solve the differential equation that is 2d square plus d minus 1 into y is equal to 16 into cos 2x. Here also, the complementary function as well as that we need to find out what is the particular integration. Because of here also, find the general solution. Therefore, the total solution is nothing but complementary that is yc plus ypa. Therefore, the complementary function it is already given in terms of the operator form. Now, we need to find out what is the auxiliary equation. with the help of the auxiliary equation, we need to find out what about the m values. Therefore, according to this equation, it is nothing but by solving that it is equation is in terms of m, the roots are m is equal to that is a 1 by 2 comma minus 1 by 2 by using the factorization or synthetic division. Here, the roots are the different, that is a case 1. Therefore, with the help of the complementary function, the condition case 1 type 1, that is c1 into e power of 1 by 2x plus c2 into e power of minus x is the value. Now we need to find out what is the particular integration of the given differential equation. Therefore, the particular integration, that is ypa is equal to 1 by f of d into q. Therefore, 1 by f of d is nothing but 1 by 2d square plus d minus 1 into q is equal to, that is 16 into cos 2x is the value. Here, the type 2, it is a cos of x plus or minus b. Now we need to follow according to clearly it is satisfied d square is equal to that is a minus a square. Here a is equal to that is a 2. Therefore d square is equal to minus a square is a minus 4 is the value. Therefore, the denominator wherever it is a d square, you need to replace that is a minus a square only. Therefore, it is a 16 by 2 into minus 14 minus 4 plus d minus 1. Why? Because it is not involving any d square. And again the into cos 2x is the value. Therefore, the total equation is a 16 by d minus 9 is the value. Once again, it is a denominator which is involving in terms of d only. Therefore, we need to eliminate the d for the purpose of the d square is equal to, we need that according to the type 2. Here also, according to the rationalize with the help of the d plus 9 by, that is a d plus 9. Therefore, the numerator it is a 16 into d plus 9 by, that is d minus 9 into d plus 9, that is nothing but d square minus 9 square. Therefore, the equation is a 16 into, that is a d square minus 81 into d plus 9 into cos 2x is the value. Now here, when we are going to observing here, it is a denominator which is clearly the d square is available. Once again, we need to replace the d square equal, that is a minus a square. Therefore, it is a minus 4. According to the d square is equal to minus a square is equal to minus 2 square is equal to minus 4 only. Therefore, the numerator is 16 by denominator minus 4 minus 81 into the first part is a d of cos 2x plus 9 into cos 2x. According to the d is nothing but that is a derivative. The derivative of cos 2x is a minus 2 into cos sin 2x is the value. Therefore, here already the denominator it is a negative is there. By using the numerator it is a minus, that is a negative. Therefore, the totally the equation it will be, that is a positive only. Therefore, the equation is a 16 by 85, that 2 into sin 2x. The second term, which is only that 9 into cos 2x is the value. After that, could come on the negative of the second term also. Now, the complete solution of the given differential equation is a y is equal to the complementary function plus particular integration. Therefore, it is a c1 into e power of x by 2 plus c2 into e power of minus x plus 16 by 85 into, that is a 2 into sin 2x minus 9 into cos 2x is the final complete solution of the given differential equation. Now, we will discuss the solve that equation d square by dx square plus 4 into y is equal to sin 2x. Therefore, here also it is clearly the given equation is the operator form. Now, we need to find out what about that complementary function, that is by using the auxiliary equation. Therefore, that auxiliary equation is nothing but by replacement of d is equal to m. Therefore, that m square plus 4 is equal to 0 or d square plus 4 is equal to also 0. Therefore, by solving that second order, that is a differential equation, therefore, the d is equal to plus or minus 2a is the value. It is clearly in the form of the complex value. Therefore, with the help of the complex roots, that is a yc is equal to c1 into cos 2x plus c2 into sin 2x is the value. Because of here, the real part is 0, therefore 0 plus or minus 2a is the value. Now, we need to find out what is the particular integration. That is, particular integration is equal to 1 by f of d into q. Therefore, 1 by d square plus 4 into sin 2x is the value. Here, according to the type 2, when we are going to replace the d square is equal to minus a square, the denominator it is vanishes, that is 0. Because of the d square is equal to minus a square, that is nothing but minus 4. Therefore, minus 4 plus 4 is the denominator, which is a 0, that is vanishes. Therefore, the case is a failure. In case of failure of the case, therefore, you need to multiplying with x into, that is 1 by f dash of minus a square into sine of the formula. Here, by applying the multiplication with x, the denominator derivative, that is a x into 1 by 2d into, that is sine 2x. And again here, x by 2, it is clearly, that is 1 by d of, that is a sine 2x is a value. And again it is a, d is nothing but the derivative, it is a single term if it is involving, but it is a 1 by d is nothing but, that is a inverse of the derivative, it is nothing but the integration. Therefore, integration of that is a sine 2x is nothing but minus cos 2x by 2 is a value. Therefore, it is the solution is a minus x by 4 into, that is a cos 2x is a value. Hence, the complete solution of the given equation is a y is equal to c1 cos 2x plus c2 sin 2x minus x into cos 2x by, that is a 4 is the final solution. Now we need to discuss, solve that d square plus 9 into y is equal to cos 3x. And this is also, while we are going to observing the previous problem, the same related to this one here also, but it is a 4 is equal to, it is a 9. Now we need to check it, what is the solution of this equation. Therefore, here also we need to find out what is the auxiliary equation. With the help of the auxiliary equation LHS side, that is m square plus 9 is equal to 0, and that is m is equal to, that is a clearly plus or minus 3 is a value. Therefore, it is also clearly in the form of the complex roots, that is 0 plus or minus, that is I into 3. Therefore, it is in the form of alpha plus or minus I beta is a complex roots. Therefore, with the help of the complex roots, that is e power of alpha x into c1 cos beta x plus c2 sin beta x is a value. Now we need to replace in the formula, that is e power of 0x is a 1. Therefore, we neglected, that is a real part. The imaginary part is only considered, that is a c1 cos 3x plus c2 sin 3x is the value. Now we need to find out what is the particular integration of this equation. There is a ypa is equal to 1 by f of d into q. Therefore, 1 by f of d is equal to d square plus 9 into that q is equal to, that is cos 3x. According to here also, the type 2, that is a d square is equal to minus a square. The denominator it is a 0 because of d square is equal to minus a square is equal to minus 9. It is minus 9 plus 9 is the denominator, it is 0. Therefore, case of failure. According to the case of failure, then what it is here? Multiplication with x into, that is a by denominator derivative. Therefore, x by x is a multiplication into 1 by, that is a 2 into d into sine of, that is a sine 3x. And here also, that is a, it is nothing but, it is a x by, that is a 2d into, that is a cos 3x. Therefore, it is nothing but x by 2 into, that is 1 by d of, that is a cos 3x is equal to, clearly we obtain, that is a x by 6 into, that is a sin 3x is the value. Because of here answer 1 by d into cos 3x is nothing but the integration of cos 3x is equal to 1 by 3 into, that is a sin 3x. Here already it is a 2, therefore x by 6 into, that is a sin 3x is the value. Hence, the general solution of the given differential equation is a complementary function plus particular integration is equal to c1 cos 3x plus c2 sin 3x, c1 cos 3x plus c2, that is a sin 3x, plus x by 6 into, that is a sin 3x is a final solution. Now we need to check it, that is solve that y double dash plus 4y dash plus 4y is equal to 4 cos x plus 3 into sin x. And here in addition of this problem, it is given that clearly, that is a y of 0 is equal to 0 and y dash of 0 is equal to also 0. That means in this problem, the problem is given in addition of here, that is a initial value problem. That means after getting the final solution, we need to eliminate with the help of, this is the initial values. You find out whatever the values are c1 comma c2 that depend upon the given second order differential equation. First, we need to find out what is the complementary function. Before going to discuss that one, we need to find out what is the auxiliary equation. Therefore, the auxiliary equation is nothing but by replacement of the d is equal to, that is a m. Therefore, m square plus 4m plus 4 is equal to 0. The roots of the equation is a m is equal to, that is a repeated. The repeated roots are, that is a -2 comma -2 is a value. Therefore, with the help of the repeated roots, the complementary function, the solution is a c1 plus c2x into e power of minus 2x is the value. Now we need to find out what is the particular integration. Therefore, the particular integration of this equation is a 1 by, that is a d square plus 4d plus 4 into, that is a 4 cos x plus 3 into sin x is the value. And moreover here, the right side is a cos x as well as the sin x in both the terms, which is a x coefficients are 1 only. Therefore, we need to put, that is a d square is equal, that is a square, that is a is equal, it is a 1 only. Therefore, minus a square is nothing but it is a minus 1 square. Therefore, the value is equal to minus 1 only. Therefore, according to the denominator, while we are going to replace the d square is equal to minus a square is equal to minus 1, the equation is changed to like clearly 4 cos x plus 3 into sin x by 4d plus 3 is the value. And here, after replacement of here, the denominator which is not at all completed, satisfied. Why? Because once again in the denominator which is involving in terms of d also. Now, again we need to multiplying like according to the rationalize with the help of, that is 4d plus 3 by 4d plus 3. Therefore, it is already plus 3 is there available. Therefore, we need to multiply, that is 4d minus 3 by 4d minus 3, the rationalize, into, that is 4 cos x plus 3 sin x by, that is 4d plus 3. The numerator it is clearly 4d minus 3 into, that is 4 into cos x plus 3 into sin x. But the denominator, that is a minus b into a plus b. Therefore, a square minus b square. Therefore, 4d square, 4d whole square minus 3 square, it is nothing but 16 into d square minus 9 is the value. Once again, we need to replace, that is a d square is equal to the denominator which is clearly available, that is a minus a square is equal to minus 1 square is equal to minus 1. Therefore, the denominator is changed to like that minus 16 minus 9. The numerator is, there is no change, that is 4d minus 3 into, that is 4 cos x plus 3 into sin x is the value. Now, we need to multiplying individually the numerator, that is a 4d minus 3 into 4 cos x plus 3 sin x. That is nothing but 4d of 4 cos x is nothing but that 4 into derivative of 4 cos x is a minus 4 into sin x. Therefore, it is clearly by multiplication of the numerator part. After the total simplification, you obtain that there is a minus 16 into sin x plus 12 into cos x minus 12 into cos x minus 9 into sin x by, that is a minus 25. After that simplification, you obtain that clearly it is a minus 25 into sin x by minus 25. Once again, it will be cancelled. That is the numerator and denominator with minus 25. The final solution is the particular integration is a sin x is the value. Now, we need to write that general solution of the equation is a, that is y is equal to the complementary function plus together the particular integration. Therefore, that is a c1 plus c2x into e power of minus 2x plus, that is a sin x is the value. But here, this problem it is not a completed, because of in this problem once again given that initial value. That means in this whatever we form that final solution of the given differential equation, it is a considered with the help of the initial value problem, that is initial value conditions, we need to eliminate whatever that c1 comma c2 is a value. Therefore, according to that first one, it is y of 0 is equal to 1, 0. By using the equation 1, that is nothing but you get that c1 is equal to directly 0 by replacement of in that equation 1 with x is equal to 0 and y is equal to 0. That means that is y of 0 is equal to 0 is nothing but it is meaning of it is x is equal to 0 and also y is also 0. By using the equation 1, you obtain that clearly c1 is equal to 0. And equation 1 is derivative with respect to x. Then you obtain that y dash is equal to some c1 plus c2x into minus 2 into e power of minus 2x plus c2 into e power of minus 2x plus cos x is the value. Once again, the given differential equation is initial values are y dash of 0 is equal to 0. Therefore, that is nothing but x is equal to 0, but here y dash is equal to 0. Therefore, by using these are the two values, when we are going to replace in the second one equation, that is minus 2c1 plus c2 is equal to plus 1 is equal to 0. Once again, already we know that that is c1 is equal to 0. Hence, by using this equation, that is c2 is equal to that is minus 1 only. Therefore, the required solution of the equation from the equation 1, after replacement of c1 and c2, the final equation is a minus x into e power of minus 2x plus there is a sin x is a final solution. This is especially whenever the given differential equation is involving, there is initial value problems. That means finally we eliminate the constants of the C1 comma C2 that depend upon the equation. Then you eliminate that is the meaning. Now we need to solve the differential equation d square plus d plus 1 into y is equal to that is a sine 2x. Therefore, the auxiliary equation is a complementary function purpose. We need to find out what is the auxiliary equation. Therefore, the auxiliary equation is a m square plus 2m plus 1 is equal to 0. Now we need to find out that roots of the m. Here it is a second order differential equation, that is a linear equation. There is an auxiliary equation. By solving that m by using the factorization or quadratic form or something synthetic division, you obtain that m is equal to minus 1 plus or minus root 3 I by 2. Therefore, it is also nothing but clearly minus 1 by 2 plus or minus I into that is root 3 by 2. Therefore, it is in the form of alpha plus or minus I beta is a value. That is nothing but the complex value. Therefore, with the help of the complex roots, it is the real part is alpha is equal to minus 1 by 2. The imaginary part beta is equal to that is root 3 by 2. Therefore, the case 3 by using the complex roots, yc is equal to that is a e power of minus x by 2 that is alpha x into c1 cos beta x plus c2 sin beta x is nothing but c1 into cos root 3x by 2 plus root 3 plus c2 into that is a sin root 3x by 2 is a value. Now we need to find out the particular integration, that is 1 by f of d into q, that is 1 by d square plus d plus 1 into sin 2x is the value. According to here, the type 2, you need to replace the d square is equal, that is a minus a square is a procedure. Therefore, d square is equal to minus a square is nothing but minus 2 square is equal to minus 4 is the value. Therefore, wherever the d square, you need to replace the minus 4 plus d plus 1 in the denominator. After that, here, you obtain that sin 2x by that is a d minus 3. Once again, we need to rationalize with the d plus 3 by that is a d plus 3. Therefore, the numerator is a d plus 3 by into sin 2x by there is a d square minus 9. Once again, here, the d square is which is available. Therefore, once again, you need to replace the d square is equal to that is a minus 4 is the value. Therefore, the numerator d plus 3 into sin 2x by the denominator minus 4 minus 9. Here it is clearly that is a denominator is a minus 13. And now we need to multiplying the numerator with individual values. The d of sin 3x, sin 2x plus 3 into that is a sin 2x. Therefore, the d of sin 2x is nothing but the derivative of sin 2x. That is nothing but 2 into cos 2x plus 3 into sin 2x by denominator minus 13 is a value. Therefore, the complete solution of the given differential equation is a y is equal to complementary plus that is a particular integration. With the help of here, e power of minus x by 2 into c1 into cos root 3 by 2x plus c2 into sin root 3 by 2x plus that is a minus 1 by 13 into 2 cos 2x plus 3 into sin 2x is the final solution. Therefore, these are the problems which are here. According to once again, when we are going to discuss here also that f of x is a sin of x plus or minus b or cos of x plus or minus b, same. Now we'll go to discuss this is also same the condition. And here also when we are going to discuss that some problems, that is solve the differential equation d square plus d minus 2 into y is equal to that is sin 2x sin x. Therefore, the auxiliary equation of the equation is similarly here also m square plus m minus 2 is equal to 0. Therefore, m is equal to minus 2 comma 1. Therefore, these are also the different roots of the given differential equation. With the help of that different roots, there is a c1 into e power of minus 2x plus c2 into e power x. The particular integration is 1 by f of d into function. And here also 1 by f of d is nothing but d square plus d minus 2 into sin x. And here also replace the d square is equal to minus a square is minus 1. And here also 1 by d minus 3 into sin x. Therefore, here also the denominator which is not involving any d square. Further proceeding, we need to rationalize with d plus 3 by d plus 3. Therefore, that is a d plus 3 by denominator d square minus 9 into sin x is a value. Therefore, it is nothing but according to that denominator is replace the d square is equal to once again that minus 1. Therefore, it is a d plus 3 into sin x by that is a minus 10. Then, you need to multiply the denominator d into sin x plus 3 into sin x. Therefore, the d into sin x is nothing but the derivative of sin x, that is a cos x. Therefore, minus 1 by 10 into cos x plus 3 into sin x. Therefore, the solution of this complete equation is a c1 into e power minus 2x plus c2 into e power x minus 1 by 10 into cos x plus 3 into that is a sin x is a solution. One more example, it is a solve the differential equation, that is a d square plus 2d plus 1 into y is equal to, that is a cos square x is the value. And here also the equation is, while we are going to observing the right side, it is not a clearly in the form of the cos ax. It is a cos square. At the time of that finding the particular integration, we need to converting into standard form. But before going to discuss that one, we need to find out what is a complementary function. That is, first we need to find out the auxiliary equation. That is m square plus 2m plus 1 is equal to 0. Therefore, m is equal to the repeated roots minus 1 comma minus 1. With the help of the repeated roots, c1 plus c2x into e power of, that is a minus x, or nothing but e power minus x into c1 plus c2x also. Therefore, the particular integration 1 by f of d into q of x or f of x, that is 1 by f of d into cos square x. Now, it is not a cos ax. Therefore, we need to converting into standard form, that is with the help of the 1 plus cos 2x by 2 is a value. Therefore, 1 by 2 into, that is 1 plus cos 2x by, that is a value. Now we need to divide individually the two parts. That is 1 by 2 into, that is a, one of the part is 1 by d square plus 2d plus 1 into e power 0x. Another part is 1 by 2 into 1 by d square plus 2d plus 1 into cos 2x is a value. And here also, we discuss one of the problem here itself like that. It is a, one is a part is based upon that case 1 e power of ax, and second part is a type 2, that is a case 2 cos ax. In that first part, we need to replace the d is equal to, according to the case 1, that is a, that is a d is equal to 0. Therefore, the first part it is, there is no changes, only the value is 1 by 2. The second part it is 1 by 2 into 1 by, that is 2d minus 3 into, that is cos 2x. Because of, according to the second part, you need to replace in the d square is equal to minus a square, it is a minus 4. While we are going to observing here, the second part which is not a completed, why once again it is involving in terms of the denominator d is a value. Therefore, we need to rationalize with 2d plus 3 by 2d plus 3. Therefore, further we obtain here 1 by 2 plus 1 by 2 into, that is 2d plus 3 by the denominator a plus b into a minus b. That is nothing but the rationalize the denominator. You obtain that 4d square minus 3 square. Therefore, the denominator once again that replace the d square is equal to minus a square. And again after the simplification, it is 1 by 2 plus 1 by 2 into, that is 2d plus 3 into cos 2x by, that is a minus 25 is a value. That means after replacement of d square is equal to, that is a minus 4, that is a case 2. Now we need to multiplying the second part in the numerator with respect to, that is a 2d plus 3 into cos 2x. Therefore, 2d into cos 2x is nothing but the derivative applying. The second part is a 3 into cos x, there is no change. Therefore, that is 1 by 2 into minus 1 by 50 into, there is a minus 4 sin 2x plus 3 into cos 2x is the final. Now, we need to consider what is the general solution of the equation. Therefore, the general solution of the differential equation is y is equal to the complementary function plus particular integration. Therefore, here, with the help of the complementary as well as the particular integration, that y is equal to e power minus x into, that is c1 plus c2 into x plus 1 by 2 minus 1 by 50 into minus 4, that is sin 2x plus, that is a 3 into cos 2x is a final solution. Now we'll go to discuss that another problem. To solve the differential equation, that is a d square plus 9 into y is equal to, that is a sin 2x into cos x is the value. Here also, first we need to discuss what is a complementary function, and after that we will discuss that is a particular integration. According to the complementary function, here the problem we need to converting into auxiliary equation, that is by replacement of d is equal to, that is m. Therefore, that is a d square plus 9 into y is equal to 0 is nothing but m square plus 9 into y is equal to 0. Therefore, by solving here the factorization method, that is m is equal to, that is a plus or minus 3i. Here the roots of the equation is nothing but 0 plus or minus, that is I into 3. Therefore, it is nothing but alpha plus or minus I beta. It is nothing but e power of alpha x into, that is a c1 into cos beta x plus c2 into, that is a sin, that is a beta x is the value. With the help of this formula, it is a complex roots, that is a c1 into cos 3x plus c2 into sin 3x. Because of here e power of 0x is nothing but 1. Now we need to find out what is the particular integration, that is 1 by f of d into q. Therefore, 1 by, that is a d square plus 9 into, that is a sin 2x into cos x. While we are going to observing here, this problem is, it is clearly not at all directly standard formula. Why? Because it is a given the problem sin 2x into cos x is a given products. But as per the working rule, we need to standard form either the sin of ax plus or minus b or cos of ax plus or minus b is a required. Here we need to, by using the component and multiple angle formula, sin a cos b is nothing but that is a sin of a plus b plus sin of a minus b by 2 is the formula. By using that one, it is, while we are going to do that, it is the sin of a plus b plus sin of a minus b, that is a by 2 is a value. Therefore, by using here a is equal to 2 and b is equal to that is a 1. Therefore, 1 by 2 into the equation is changed to 1 by d square plus 9 into that is sin 3x plus sin dx is a value. Therefore, 1 by 2 into that is dividing individually that 1 by 1 the two terms, 1 by d square plus 9 into sin 3x plus 1 by 2 into that is 1 by d square plus 9 into sin x is a value. Now, in the first part, we need to replace the d square is equal to that is minus a square is a value minus 9 because of minus 3 square is equal to minus 9. And in the second part, that is a d square is equal to that is a minus a square is nothing but it is a minus 1 square. Therefore, it is clearly in the first part it is a d square is equal to minus 9. Second part it is a d square is equal to minus 1 is value. Therefore, by using these are the two values, after that replacement here, the particular integration is changed to 1 by 2. But whereas in the first part, it is a denominator provided 0. According to the case failure, first part, that is a multiplication with x into 1 by 2d into that is a sin 3x is a value. And again the second part, it is a not denominator 0, directly the solution is 1 by 8 into that is sin x. Therefore, the first part it is a 1 by 2d is nothing but once again the integration of the sin 3x. By using the integration part and again that after the simplification, that is x minus x by 12 into cos 3x plus 1 by 16 into sin x is the value. Therefore, the complete solution of the given differential equation is the complementary function plus particular integration together. There is a c1 cos 3x plus c2 sin 3x plus minus x by 12 into there is a cos 3x plus 1 by 16 into that is a sin x is the value. Now we need to check it, that is a solve d square plus 1 into y is equal to that is sin x into sin 3x. And here also, first we need to find out complementary function with the help of the auxiliary equation. That means replacement of d is equal to m. Therefore, m square plus 1 is equal to 0. That m is equal to clearly here also the complex roots, that is also 0 plus or minus I. That is also c1 cos x plus c2 sin x is a value. Now we need to find out the particular integration. And here also that right side is a given problem is sin x into sin 2x. But it is also not a standard form of the right side in the particular integration. Therefore, we need to converting into standard form by using the value of 2 into sin a into sin b is equal to cos of a minus b minus cos of a plus b. By using this formula, we need to change it to like that 1 by 2 to cos x minus cos 3x by that is a d square plus 1. And here also the two parts are available. One of the part is a cos x by, second part is a cos 3x by. By solving that individually the two parts, that is a particular integration 1, particular integration 2. And in the first part, it is a denominator by replacement of d square equal that is a minus a square, that the denominator vanishes 0. Therefore, that is by using the case of failure, that value is a x by 2a into sin x, that is nothing but x by 4 into sin x is a value. We need to find out the particular integration 2, second part, that is 1 by, that is a d into, that is a 2 into minus cos 3x by that is a d square plus 1. Here also by using that d square is equal to that is a minus 3 square is a minus 9. Therefore, the particular integration is equal to minus 1 by 2 into cos 3x by it is a minus 9 plus 1. That means that is a second part is equal to cos 3x by that is a 16. And again, now we need to find out what is the general solution of the equation is a complementary function plus particular integration together. Therefore, c1 cos x plus c2 sin x plus x into sin x by 4 plus that is a cos 3x by that is a 16 is the solution. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.